Okay, we thought that maybe using the serial monitor, we needed a little bit of an introduction to that. And while we're doing the introduction, we might as well do something useful with it. So we're going to use the serial monitor as a debugging tool. Probably one of the few that are available. There's some other different things you can do, but one of the ways that are there. So first off, the serial monitor allows a connection between an Arduino and the PC, and it can send serial data back and forth. So obviously, there's no wireless connection, so you have to have the USB cable connected up. But while the program's running, you can use special commands, and you can get data back and forth in both directions. So that's what we're going to show. Rather than type the program in from scratch, which takes a while, we thought we'd give you an example. So you can see here my comments at the top, my sort of template. So I always have comments at the top, and it says the name of the program, my name, the date, what hardware I use to test it, and a short description of what's going to happen here. By the way, this ends up in a section, and I can expand or contract that using the new beta version of the IDE, which you could do this with the old stuff too. It's not going to be any different. Okay, just remember to get what I have on the screen. I'm going to do File Preferences. I made sure I checked the Editor Quick Suggestions. Right now, this goes away. Every time you bring it up, you have to do it. Eventually, they'll fix that in the beta. And I changed to the dark theme. So as I said, this is going to work exactly the same way on the existing Arduino IDE interface. So I'm gonna contract this. I'm going to get it out of the way so I can see it. The next thing that I do in my template for a program is declare the variables for the program. In this case, we're going to use two. The first one is a Boolean data type. It's going to be called debug, and we're going to set an initial value of false. The second one is going to be an integer data type. The name is going to be X, and it's going to be also have an initial value of 0 set. With the initial value is an option. You don't have to set it. In this case, it's useful. Always when I put variables in here, I try to make them useful names. Debug is useful. X is what I always use for a loop counter. But I also put comments for that on here. Okay, so that's done. There's no section there. That's still part of this big section just below that. So I can't expand or contract that. So I come down here to setup, and setup is where we're going to put the code that just runs one time. In this section, we got to do two things. We want to use an LED, and we've done that before. So the pin mode command you're used to, and the built-in LED built-in is just the defined name, so I don't have to go look up the number that the onboard LED is connected to. So this is defined somewhere else in the IDE environment. Same way with output. So we're setting that up as an output pin so I can flash that LED on and off. The new thing, serial.begin, is a command to work with the serial monitor. As we said before, it's RS-232 a serial connection, not necessarily RS-232, but it runs through the USB cable that connects the Arduino to the PC. And to use it, you have to initialize it. You have to tell it that you're going to use it, and that's what the serial begin command does. And this 115200 sets up the speed. I usually crank that up as fast as I can so that I'm there. And this little button up here in the top right-hand side of the screen is what initiates the serial monitor. So when I turn it on, you see it comes on at the bottom of the screen. You also see down here is a pull down. You have to set this up for the exact speed that you use in your serial begin. You only have so many choices for that. So you heard me say I crank it up to the fastest speed. I've already run this program, so it's already set up. Okay, I'm going to go back to the output screen. There's tabs down here now that you can switch back and forth now that you have the serial monitor up. We're going to switch back to the output screen because we're going to want to watch this program as it downloads to make sure it works. So we only want serial begin and pin mode to happen once. And, you know, we set up that as an output pin so that we can send signals to that LED, and we set the serial port up once. The speed, the serial monitor, and we never change it after that. Okay, so once again, nice little feature of this new IDE is I'm done with the setup. I can get it out of the way so I can see more stuff in the program. And then the loop is where everything's happening, right? That's the repeated part. When it finishes at the bottom of the loop, it comes back to the top. We put a couple new things in here. They're not very complex, pretty easy to do. First thing is there's a series of if debug commands, and then within there, that structure, the if structure, are a couple commands that will execute if debug is true. And debug is a value that we defined at the very top of our program, a variable, and I set it to false. So right now, none of these if statements are going to go true, and nothing inside of here is going to happen. So if debug just looks at a Boolean value, false or true, and tells you whether you execute the code inside of here. So we'll sort of forget those right now. I can smash them down if you want to, or I can expand them. They're not really in the way. We're going to come back to them very shortly. But we looked at a program very similar to this before where it turns an LED on high and then it delays for 1,000. And at the top it did an if debug, and here it does an if debug, and it prints something out if the debug's set up. The second group of related instructions is digital write to turn the LED off. There's a debug command inside of there, delay for 1,000, and then there's another if debug that happens down here. And then finally, at the very beginning, before we go back and do the loop again, we're going to take our loop control variable, which keeps track of how many times we've been in the loop, and add 1 to it. So that's going to keep track of how many times the loop has occurred. Now, back to this debug a little bit. As long as it's false, none of these things are going to happen. And what I put them in here for is once I get this program up and running, we looked at this flashing light thing. You can see the light flashing, but as your program gets a little bit more complex, it might be nice to know where it is in the program when it's running and executing. And these serial print commands will send information out to the serial monitor to do that. So the purpose of these debug statements are to help you debug your code. Yes, it's a very simple program. It doesn't seem very helpful at this point, but as you get a bigger program, it will be. So it's easy to follow right now. So at the top of the program, if I have this set to false, and I send this program over to my Arduino, none of these things are ever going to happen. So it's almost like you just have these digital write and delay commands in here like you did before. However, if I change this to true, and there's other ways to tell whether this is going to happen, these commands are going to happen or not. This is probably the least desirable way because I have to go in and make a change and re-download the program. In the future, we'll show you some more as we add some commands. But as soon as I set that to true, all these statements are going to happen, and they're going to, at each point, they're going to make something print out. So at this first statement up here, I'm going to serial print the value of X, the current value of the loop counter, and we're going to do that in decimal format. You can look up the serial print command at the Arduino reference section and see what's there. Serial print, by the way, prints and then does not go to a new line. It just sits that part on the line. So if I do another serial print after there, something will print after it. So my second command here is a serial print line, and you'll notice it says it's going to print a space and then start of loop. And it's going to end it, and print line instead of print says after this executes, go to the next line. Do a carriage return and get to the next line. So if you look here, the debug is going to tell us what's happening in this program, so we know sort of where it's at any point as this runs through here. And you're going to see a series of these here. You can look down through this program and see what happens. So I'm going to send it over to my Arduino. I have it hooked up. I'm not going to show it to you. Not the most exciting thing. But you can see my output saying it downloaded it. I'm going to click back over to the serial monitor. And down here, you will see the results of the fact that the debug is true. And each one of these things causing a line to print out. And it's pretty neat. It does slow down the execution of the program when you do this. That's why I have the false and true in there, so I can turn it off and the program will run faster. But in big long programs, putting debug code in and allowing it to be conditionally run or not is probably a good thing. Some other things while we're here. See this at the bottom right side here. This will toggle this panel off so that you can look at more code at one time. So you can see the full program here. And I'll leave that up there for a second in case you want to pause it and see what's there. And then if I hit that back again, it'll toggle this back on. And also remember the output display from when I do my compiling the program. And another tab over here called the serial monitor is what lets you go back and forth. If you want to get rid of the serial monitor tab, click on the serial monitor button in the top right hand time again, and that'll get rid of it. And that's just a quick introduction with a meaningful use put to it. So hopefully you can start fooling around with the serial monitor and enhancing your program a little bit, or do it. It is the only way without interfacing a display to have something from the actual execution of the Arduino code while it's running, to have something be visual. Okay, we'll advance this topic in the future.